Hello, this is Mr. Spencer, and we're continuing on our discussion of categorical data. And right now we're going to look at two-way contingency tables. We are on page 44 of the note spiral. Page 44 of the note spiral. I'm going to tell you that we will talk about contingency tables here in displaying and describing data, and then we'll pick them up again in probability because they are we use them to actually calculate probabilities, but for the time, or to create them and calculate probabilities. So we're going to learn some definitions. First off, they're useful in showing relationships between two categorical data and provides the frequency or currency across each variable. All right. So first off, we have some definitions. The marginal frequencies are the frequencies as the column or row totals. So these represent the marginal frequencies. And you're like, hey, you didn't subtract, you didn't circle 112, and you're right, I did not. 112 is the total of our sample. It is not a marginal frequency, it's the total frequency, all right? So that is not a marginal frequency. And the joint frequencies, so basically in this case, a marginal frequency, 48 times we had low cholesterol, 37 times we had medium cholesterol, 27 times we had high cholesterol, 64 non-fatal heart attacks, 48 fatal heart attacks. That's the frequency. Now that is in contrast to the joint frequency, all right? The joint frequency, and that's not how often some of your friends made bad decisions, all right? So this is the joint frequency. And the joint frequency says 29 times we had low cholesterol and a non-fatal heart attack. 19 times they had low cholesterol and a fatal heart attack, all right? So that's the way this worked. Now, please remember, rows must sum up and columns must sum up, and then everything sums to the total, all right? So if I add up if I add up this set of marginals, it equals 112. I add up this set, it equals 112. Add up these values, it equals 64. Add up these values, it equals 48. All right? So how many variables are there? Well, in this case, I have two variables. I have severity of heart attack, and I have cholesterol level. All right? Severity of heart attack is listed here, and then I have cholesterol level up there. How many levels are there for each one? Well, heart attack has two severity levels, fatal and non-fatal, and cholesterol has three levels, which are low, medium, and high. The sample size in this table is 112. That's the frequency. The next thing says list the joint frequencies. Well, we have non-fatal of 29, medium of 17, non-fatal and low, let me rephrase that. Non-fatal and low is 29, non-fatal and medium is 17, non-fatal and high is 18. Fatal and low is 19, fatal and medium is 20, fatal and high is 9. The marginal frequencies we've already talked about, and so 48 low cholesterol, 37 medium, 27 high, 64 non-fatal, 48 fatal. And what you should have noticed is when I listed the marginals, I only listed one thing. When I listed the joint, I had to mention low cholesterol and the severity of the heart attack, the cholesterol level and the severity of the heart attack for each one of them, because it was joint, it was combined, all right? The next thing it asks is, are the variables independent? Well, if they're independent, they need to be proportional, all right? To be independent, things must be proportional. We said that in video 17 and in video 18. So looking at this, I can sit there and go, well, 29 over 48 does not equal 17 over 37, does not equal 18 over 27, does not equal 64 over 112. Now, if you're not sure, you can go ahead and divide those out into decimals and compare the decimals. Now, some people say, well, what if they're really close? If they're really, really close, then you probably might say, you know what, it's possible that they're independent. But my best response would be, if they're close, to say they're close, we're not sure, so we need to do further, we need to get some more data to check that out to see if they might be independent or not, okay? But to be independent, those proportions need to be actually the same. So it also says, please continue to use the table that we were just using to answer the following questions, and we're now on page 45. What percent of the people in the sample had a fatal heart attack? All right, well, that's going to be 48 out of 112. The 48 fatal heart attacks out of the total population. What percent of the people in the sample have low cholesterol? Well, that's also 48 out of 112. All right, those are marginal probabilities because they're dealing with the values from the margin. What percent of the people in the study had a high cholesterol level and had a non-fatal heart attack? High cholesterol level and had a non-fatal. That would have been 18 out of 112. And that's a joint probability because it's a part of the whole. All right. I mean, we took the the combination of high cholesterol and non-fatal together. What percent of the population, percent of the people had a medium cholesterol and had a fatal? So medium and fatal was 20 out of 112. So 20 out of 112, or 17.9%. Now we get into conditional probabilities, and I need you to pay very close attention to this. Conditional probability means we've added an additional condition or restriction. Really, it means something even better than that. It means we know something. It means we're not any longer looking out of the total 112. We're looking out of one of the marginals. We don't know which marginal, depending on the question. That can change. But depending on what the question is, we're looking at one of the marginals. So it's a conditional probability is a joint frequency of over a marginal frequency. And typically we're looking for the words and or both and something that says given. All right, and or both and something that says given. So given that a person had a fatal heart attack. Oh, the given's always in the denominator. So they told me they had a fatal heart attack. So right away, that tells me 48 is going in the denominator because that's what given. What is the probability they had high cholesterol? Okay, so I'm looking at the fatal heart attacks. Hold on just a second. I'm going to write a little bit down because I think this will help us out. 64, 48, 112, 48, 37, 27. All right, so they said given that they had a fatal heart attack, so I'm now looking at the fatal heart attack column. That's my given, given's in the denominator. Then the next part of the question is, given that they had a fatal heart attack, what's the probability they had high cholesterol? All right, so there you see it. I have an intersection. So that intersection is what goes in the numerator, okay? We often use this symbol in statistics to represent, or in probability to represent an intersection. The next part, given that a person had low cholesterol, so all right, now we're focusing on the low cholesterol family. Low cholesterol was 48, so given that they had low, which is 48, what's the probability they had a fatal heart attack? Well, low cholesterol, that's this, fatal heart attack, 19, so 19 out of 48. And yes, you can leave it as a fraction if you like, or you can convert it to a decimal, or you can convert it to a percentage. I like for you to at least, well, you must always show the fraction, and I prefer that you write the fraction and then convert it to a percent form. So given that a person had a moderate cholesterol level, so given that they had a moderate cholesterol level, And I looked at this and I was like, okay, 37 had the medium cholesterol. What is the probability they had a non-fatal heart attack? So how many had non-fatals and were medium? 17. I covered that up for you. 37 had medium cholesterol, 17 had the non-fatal. So in that case, it'd be 17 out of 37. 17 out of 37. Please complete the table using percentages instead of frequencies. So all I did was divide every single table value by 112. So we had 29 here, 29 divided by 112. This was 9, 9 divided by 112. All right, so please remember, given is always in the denominator, and if that's the case, we are looking for an intersection in the numerator, the intersection of the two variables. Thank you. And you know what? Let me do one more thing, guys. Pause this. All right, I know that my hand was blocking some things, so I'm going to scroll through this page so that you can copy down whatever you may have missed. There's the table that's been filled in. Please note that all we did was sum the rows, or sum the rows this way and then sum the columns this way. Pause right here. And you can pause the video. Pausing right there. Remember the difference between a marginal and a joint? The marginal had a marginal over the total. A joint had a joint frequency over the total frequency. Please remember, conditional probability means given is in the denominator, and it's because we know something. We're no longer looking for the entire population. We're looking for a portion of that population. All right, we know something. All right, thank you.